Advanced Web Applications TypeScript. So, we have been learning JavaScript, but let's discuss a bit about TypeScripts. So, TypeScript, short TS, was originally developed by Microsoft, which is kind of strange that we are using now a lot of Microsoft tools which we hated 20 years ago. But this came from Microsoft, and the 1.0 was released in 2014. It was already used a few years before that, but the official 1.0 was released back then. And all JavaScript programs are valid TypeScript programs, but not vice versa. So TypeScript programs cannot be interpreted by JavaScript, but vice versa it works. Yeah, so TypeScript adds features to the JavaScript. Browsers do not support TypeScript. This is the important thing. So when you are writing TypeScript, you cannot run it in browser environment because they do not understand it. The TypeScript needs to be first transpiled, which means pretty much same as compiled, to JavaScript. After that, that JavaScript can be run in the browser environment or in the Node.js environment in the backend server side. But this TypeScript itself cannot be run. It needs to be first transpiled. What kind of features this TypeScript then provides us? The most important, it provides us statically typed things. So there is type for every variable. And it really has several data types. So whereas we had the JavaScript had only few, the TypeScript have many. Boolean, number, string, array, tuple, enum, unknown, any, void, null and undefined, never, and object. So some of them are already familiar from JavaScript. So we had booleans, we had numbers, we have strings, arrays, objects. But there are something like tuple, enum, unknown, and any that were not in JavaScript, but they are data types, property types in TypeScript. So in JavaScript, you are just defining the variable x and you are giving it a value 10. So let x equals 10. In TypeScript, you are defining the same variable x, let x, but then you are using colon and defining the type, which in this case is number, and then it equals 10. So then the compiler knows that this variable is number and it cannot store, for example, string. But luckily, TypeScript can also figure out that let x equals 10 is a number. So if you are giving a value to the variable when you are defining it, then you don't need to define the type. But if you are not giving any value, you are just defining let x. So there is a variable x, then you need to define the type also to that variable. So a bigger example, so if you are defining this number x and it's equals 10, and then you are trying to put some kind of a string there, then the compiler or transpiler will note that this does not work. And if you are using Visual Studio Code, you will know that the Visual Studio Code will underline, give a red underlining to this string and saying that this is not legal. Similarly, if you want to have an array of strings, you define let names and the type is string array, and then you are giving an empty array as a value to this names variable. So you could not just define array, empty array, because it would not have a type, but here we are defining that this array will have strings inside. Also with functions, we are using the types. So here we have a function greet. It is somehow greeting us. So we are giving a parameter, it's a string, and the parameter variable is name. And then the return value after colon, there is a string. So this is getting a string inside, and then it's returning a string. And in the function itself, it is only merging these two strings, hello, comma, space, and then the name, which is then transformed to uppercase, and some acceleration marks in the end. So this is how we define as function, and here of course the TypeScript cannot guess what are the parameter types. You need to set them manually. So function parameters and return value have the types. That is very important in TypeScript. We can also of course give default parameters, so we could give default parameter to this greet function, so the name would be Sally as a default, but this was also possible in JavaScript, but here we are explicitly setting that it needs to be string. Parameters can have also union types, which is like OR keyword. So we have a function print ID, and it's getting a parameter called ID. It can be number or it can be a string. So this ID can accept something like 42 as a number or a string, something like ID-42. Both IDs would be valid. But in the function, you could only access the operations of this ID variable that are available for both number and string. So you could not use, for example, this to uppercase method, because numbers cannot be put to uppercase. We do not have lower and uppercase for the do. You need to use type of, that's a basic JavaScript type of, which will give the correct type, and then when you have checked that it's type of number, then you can use the operations that are available for numbers, and if the type of string is true, then you can use the methods that are available to string, is like this to uppercase. And then TypeScript will provide us as aliases and interfaces. So this type alias can be used to make the code more readable, but it's something like the alias keyword. You have a word and then you are giving it an alias. Here we are defining a type called cursor coordinates, and we have two variables there, x and y, and they are both numbers. So then after that, you don't need to define everywhere like x and y. You can just use the alias cursor coordinates. And then this TypeScript will bring us also interfaces, which are very familiar from Java, for example, and did not exist in JavaScript. So we can define, let's say, interface person, and this person has attributes email, which is a string, and age, which is a number. And yes, these look very similar. So why we have a type and interface, they are looking like the same. Well, the difference is that you can add fields to interface, but not to type. So if we are defining again interface person, and now we are setting that the fax attribute is a string. So this is not overriding the interface previously defined, but this is adding this field to the person interface that you could not make with this type alias. There are plenty of other tricks to learn. I will just show a few here. So we can have literal types. So we can have a function called print year, and this is taking a parameter year, and it needs to be 1999, 2000, or 2001. So you cannot give any other value to this function. So this is, in some cases, this is very useful. So you have basically only three possible options here. Then you can have read-only and optional properties. This is also very new to JavaScript. So this interface person we can define that this email is read-only. It's a string and it's read-only. So once you set the email to have some kind of a string email address, then you cannot change it again. It's read-only. And then we are defining that this fax is optional. Then there is this question mark. So you can use this person without giving it any fax value, which is quite useful because not everyone has a fax number. But basically everyone has an email address. And then TypeScript also support generics like Java or C++. This is not covered on this course, but if you are familiar with the concept in Java or in C++, then it will be quite useful to have these kind of options in larger project. But in this course, it's you can manage without. So how does this process work with when you are using TypeScript? So first, developers code in TypeScript. So you can use Visual Studio Code or any other editor that highlights the code as a TypeScript. Is very useful. It's giving you all the necessary information to work with the code. And then this TypeScript code is transpiled to JavaScript. So basically we are using, or the automatic process is using this tsc command. You can define a file called that is going to be transpiled. Here is the code.ts, which means that the file is TypeScript, and then the output will be code.js, which will be JavaScript file. If you are not giving any parameters to this tsc, then it's automatically compiling all the codes, which is usually the case. And the third step, that code that is transpiled, it's then deployed to test or production environment, and then you can run it. This is usually quite automated process, so you don't need to worry about that. And more information about TypeScript can be found from, for example, this TypeScript Lang, the official website. It has a very good docs. It has a handbook, which you probably want to read through. And there is also this TypeScript in 5 minutes that will show you what is the actual concept of TypeScript. Let's have an example on this. Okay, we have pretty empty project here. There is just a folder TypeScript demo. Let's add a file here. It's called index.ts. So this is our TypeScript file. So let's define first my name, which is string, and then let's use this my name and set it's John Doe, and then we can log that file out. No, that file, that variable, I mean, yeah, very simple application. And now we have it here. We can actually run this completely with the Visual Studio Code just by using Node.js. And as we can see, here we have an error. So Node.js does not understand what is this colon here, because this is a TypeScript file. So first of all, we need to compile that. Let's check what we have here. So we have this index.ts. So let's first use this tsc command and init. So now we got a file called tsconfig.json. So here we have a target, module, etc. Yeah, we have the file here. Why it's not visible here, I don't know. And after restarting the Visual Studio Code, now we are seeing this file here. So this is a config file that has a plenty of options which you can modify to get out of this kind of a output JavaScript that you would like to have, or how the Visual Studio Code would like to help you with the coding. First of all, let's go and find output here. Here we have the output directory. Let's take this out of here and let's change that it will provide us the code to the dist distribution directory. And now we can compile this our code just by writing tsc. Yeah, okay, now it's there. So now we have the file, and this file can be run. So if we want to run it, we can just go here and run it. Now we got the John Doe out of it. And now we can see that this index.ts was transpiled to this index.js. So we are using strict. This is basic JavaScript that is very, very useful. It is using the strict mode so that it will pinpoint all the issues already in the coding. And we have the variable, and then we are setting the variable and logging it out. So it is now missing only this string keyword because this is not JavaScript. Let's go back to this settings file. Another important thing is if your transpiling is not producing JavaScript that would be using this let keyword, then this is too old. So if we are using, let's say, ES5, let's see what will happen. Now there is a keyword var because it's so old version, so it did not understand the keywords let and const, but we can use the ES6 version or 2016, which is now then giving us the let keyword. For example, there are different versions. So, but let's continue. Yeah, so if we would now have this my name, and let's put 666 there. Now the Visual Studio Code is hinting us that the number is not assignable to type string. So this should be string. But if we are running the tsc command here, it's giving us an error, but the actual index.js was modified, and now we have here the integer value here. And this is something which is very strange, and we do not want that. We can get rid of this by using a setting here. Here we have no emit on errors, so disable emitting files if any type checking errors are reported. So let's take this in use. And now let's remove this file here. Now we don't have the transpile file. Let's try to transpile. Nothing happened. We do not have the file here. So there is an error. It does not produce us JavaScript. So let's get rid of this. And now we can transpile it. And now we have the once again, and it actually you can in the settings you can set that comments will be removed, etc. if you wish. So what else can we do? We could have some kind of a function here called f. It takes two parameters, a, which is a number, and the default value is 0, b, which is a number, and also has a default value of 0, and it will return number, and this is only returning. So now there is underlining, so this function needs to be returning a value. We do not have any return value here. We need to first write that, and this is just returning a plus b. And now we can use this, give it a values like 10 and 15. Let's see. First let's transpile it, and then we can check. Yeah, this looks pretty same, and we can of course then run it, and it gave us 25. But you could also use this function with only one parameter, as we have a default value here. So let's compile it again, and let's run this. So now we got only 10. The other value was default 0. So what next? So let's just have a type. We could use this type to build aliases. So your name equals string. And now we can set that let your name equals, not equals, but its type is your name. So now we are defining that this your name is a string. So this is just an alias for the string in this kind of a case. And then we can set that your name equals Camilla Young, for example, like this. But this type is also useful when we are defining something else. We are defining here a object which has a read-only attribute ID, which is a number like this, and then it has an email, which is a string, and then user name, which is an optional string, like this. And now we have this kind of a definition. It has a types for all these attributes. Then we can just build a user, which is user type. So this user variable is using this type user, and here we have set all the necessary types. So we can give it an ID and email, like this. And now everything is working. If we will try to give it the ID which is a string, then it's not okay because string is not number. So here we define the types, and then we use this, and we got all the statically typed variables. Very good. And this user has this email, which is a string that we can change. So user email, let's change it, mail@mail.com. But this user has this ID, which is a read-only field, and that we cannot. Is the font big enough? By the way, let's have a bigger font here. Yeah, so the ID we cannot change, and let's try it. 6667. 667, yeah. And now the Visual Studio is giving us the warning that cannot assign ID because it's a read-only property. This is a good thing. You can have those read-only properties. And then we can log this user. Let's first transpile it. It worked, and then we can run this our file. So we got out of that the object that has ID and email attributes. So this is very simple demonstration of what is this TypeScript, what it gives us, and how it is used. So now we are using a manually compiling, transpiling the every time we are doing some modifications to our code, but this can be of course automated. So that was just a simple example what you can do with TypeScript, but where to use it actually. So besides this simple application, TypeScript can be used with Node.js and Express, or with the React, or both. React will be covered later on this course. So basically all new JavaScript framework are nowadays programmed with TypeScript. So the bigger is your project, the more important is to get rid of those stupid type errors, and TypeScript is the tool to get rid of those. You have to set the types, then you cannot mess them. So TypeScript is the tool to use here. So let's have a bigger example on how you can use TypeScript in Node.js. So let's try to build a project where we are using TypeScript and Express, and of course Node.js and a lot of other modules. So we will start this by initializing a new project. here we have now the new project. And then of course we need some modules like express. Yeah, and then let's just write a very simple server, index.js. And I'm now writing this in JavaScript. You'll see soon why. So first we will need this express. Then we will build the actual app. And we will have the port equals, let's say, 5000. We have a request and response object, and then we are just sending the text that hello from express application, like that. And of course we need to listen to this port we were having here. No, just like this. And then let's have just a short console log here that our server is actually up and running. Let's have the port here too. Now I'm once again writing porn here, but no, it's not porn, it's just port. And yeah, this should be now working. Then let's see. Now index server is up and running, and let's copy paste this line here and let's see if it's actually up and running. Yes, it is. Our Express application is there. Very good. Now we are needing a few things. So basically, if we are using JavaScript libraries or modules that are written in JavaScript, not in TypeScript, then we would need some kind of a declaration how these JavaScript files are used, and these are in so-called declaration files that end with .d.ts, and we can install a lot of these kind of things. And then we will need to generate the TypeScript config file. DSC init. And we have it here. We can change this to ES6, although it's basically the same. And then we are defining once again the output dir, which is this dist. So our application compiled transpiled files will be in this distribution directory, and we are not doing anything if we have errors. This is fine. And now we have this JavaScript file, but let's modify it just to be TypeScript file. So let's modify this extension, and now we can also modify a lot other tools. So we can use, when we are using this ES6, we can use import clauses here. So we are not requiring the whole Express, but we are getting some parts of it, like the core, request and response from Express. And now this app needs to be type of Express. This port, well, now it's already set, it's 5000, we could define its number, but it's already defined as there is this integer. The request, this is of course now request, and this response is response. Now we are quite happy with this. So now we can set that this is TS Express application, but of course now we are saving it, and we could run it, but we do not have the JavaScript file anymore. So we need to compile this thing, and we want to do it automatically. So we will need few things. So first let's install additional module called TSC watch. It will check automatically if our file is modified, and then it will compile them. And now in our, okay, let's, by the way, npm install nodemon install, and then we have this package.json, and we have a script. We have only test script here, so we can run npm run test, and it's giving us no test specified. But let's add another script there. So we are going to need a script that is going to watch the code and compile it and then run it automatically. So let's do this kind of a script, call it dev server, and the command itself is tsc watch. We just installed that. It has several parameters. And when it's successful, so the compiling has and transpiling has been okay, then we can run nodemon on this dist directory. There should be index.js, and like that. Okay, let's see. So run dev server. Error. Yeah, who on earth put n there? It should be like this. And now I'm getting this stupid error. So I have done some things. I'm not pretty sure if any of those helped. The issue seems to be with Visual Studio Code, as it's already running a Node server, and now I'm running a second and third and fourth and whatever Node server here. But now I'm using my console here, so if I'm here just running the program dev server. Now it compiled, and the compiling is in watch mode, and the server is up and running. So we have a TS program here, and yeah, it is also visible here. So if we make a change here, I am up and running like that. And if I refresh, it's also the text is here. So I did not have to run any commands after that. I have been writing this TypeScript. So the transpiling and updating the server, it was done automatically behind with this this command. So this tsc watch the TypeScript files, and when they were changed, then it automatically transpiled them, and then the nodemon is checking that if the JavaScript file has changed, then it will restart the actual server. So now I'm running this fully functioning server. And now we have the Express server that is written in TypeScript. We have defined that the application its type is Express, and these request and response, their types are request and response. So this is now in that sense much safer to run when we have the types here. And we could also actually now implement every new feature with TypeScript, and they would automatically be then transpiled to JavaScript that could be run in the server. And as a conclusion, nowadays all the bigger web applications are written in TypeScript. It makes the coding more safe when you have a statically typed language. And of course there is this downside that you need to transpile all the codes because browsers do not understand TypeScript, but this is pretty much automated in the background of the project.